Welcome to Click Academic. We will be starting a series on mathematical methods. This is lesson 1 and we will be discussing about Roles Theorem. The issue of Roles Theorem said if a function f is continuous on the closed interval a, b, and differentiable on the open interval a, b, and if f of a is equal to f of b, then f prime of c is equal to 0 for at least one number c in the open interval ab. That is to say, in the Roles theorem, the conclusion of the theorem said f prime of c is equal to 0, but under the condition f of a is equal to f of b. So, to solve a problem concerning Roles theorem, let's take an example. Example 1. The question says prove that the function defined by f of x is equal to 3x squared minus 12x plus 11 satisfies the hypothesis of Roles theorem on the interval 0, 4, and find the number c in the interval 0, 4. That is, this one is open interval while this one is closed interval, which satisfies the conclusion of the theorem. So, solution to this problem. Remember, Roles theorem has two conditions. The function must be continuous and the function must be differentiable. So, we are given the function as given f of x is equal to 3x squared minus 12x plus 11 on the interval. This is the interval 0, 4, which is our a and b. Our a here is 0 and b is 4. So, to see or to see that whether the function is continuous or not, you have to take this 0 and 4 function in the given function to see whether the function is continuous or not. So let's start with the first one. This is our a and this is our b. So let's see f of a. F of a is equal to f of 0. So the 0 here will function here in the given function. So f of 0, anywhere we have x, now it's no longer x, it is 0. So 3 into 0 squared minus 12 into 0 plus 11. Because anywhere we have x, we should now replace it with 0. This is equal to 0 squared 0 times 3, 0. Minus 2 times 0, 0 plus 11, which is equal to 11. So f of a is equal to 11. Then let's see f of b. F of b is equal to f of our b here is 4, which is equal to anywhere we have x, now we should now replace it with 4. So 3 into we have x, so our x is 4 minus 12 into 4 plus 11. So 4 squared 16. 16 times 3, 48. Minus 12 times 4 minus 48 plus 11. Minus 48 minus 48, 0 plus 11 is equal to 11. So f of a is 11 and f of b is 11. So the function now is continuous on this interval 0, 4, because f of a we have 11, which is continuous, not divided by 0, and f of b is still 11, not divided by 0. So the function is continuous. So to see the function satisfy the second condition, which say that the function must be differentiable on the open interval. So let's see, does the function differentiable? Let's differentiate the function and see. So we are given the function as this. So derivative of this function is f prime of x, which is equal to derivative of 3x squared is 6x. Derivative of minus 12x is minus 12. So the function is differentiable because we differentiate the function and we still have a variable in the first derivative. Therefore, the function is continuous on that interval and the function is differentiable on that interval. We should now say, therefore, the function is continuous on the, remember, continuous on the closed interval, and the interval is 0, 4, and differentiable on the open interval 0, 4. So since the function is continuous on that interval, closed interval, and the function is differentiable on that interval, so the function satisfies the hypothesis of the Roles theorem. And they said if the function satisfies, and if f of b is equal to f of a, yes, f of b is equal to f of a, because f of b is 11 and f of a is 11. So f of b is equal to f of a. Then they said f prime of c is equal to 0. Then f prime of c is equal to 0. And at the end, we are asked to find that number c that exists between that interval, which satisfies the conclusion of the theorem. And this f prime of c is equal to 0 is the conclusion of the theorem. So to find that number, we are to use the conclusion of the theorem to find the number. Now, this is the conclusion of the theorem. F prime of c is equal to 0. We don't have f prime of c, but if you look at the derivative of the function, we have f prime of x. So since we have f prime of x, we can find f prime of c, which means f prime of c now is equal to, anywhere we have x, we should now replace it with c. So we have 6x, which is 6c, then minus 12. This is f prime of c. But the conclusion of the theorem is that f prime of c is equal to 0. Therefore, this implies 6c minus 12, which is our f prime of c, is equal to 0. So we are looking for c. We should now collect the like term. 6c is equal to, taking 12 to the other side, minus 12 to the other side become plus 12. So divide both sides by 6. C is equal to 12 divided by 6. So 12 divided by 6, 2. Our c is equal to 2. That is the number that exists between the open interval 0, 4 is 2. That's all.